Okay, so we're going to go ahead and continue with the reviews today. We have not yet started review 3. We're going to go ahead and do so. Did we want to go ahead and talk about the probability problem, the quiz? Or, okay, let's go ahead and do that, and then we'll just get as far as we can. Not here on Monday. So I've already left instructions with the substitute. You just have the period to go ahead and work on the reviews. You have the review 3. You also have the review 4. And I'm going to have the substitute give you review 5 to go ahead and start taking a look at. And again, we'll just continue, get as far as we can. So if I could ask Caitlin and Graceland to just step outside for a few minutes because they have not had the opportunity to look at that quiz yet. Okay. Let's see if I find that chair. Okay. Well, I mean, I like to believe I can trust my students. Is there anybody who has not turned in the quiz? You said it so softly. Okay. No, I like to believe I can trust my students. We'll see. All right. But now I'm feeling all weird. Okay, now I feel like I should stop recording. You don't think so? It is true. Okay. There we go. There we make it a pact. Okay. Now, did we want to go ahead and look at the whole thing? Did we want to look at just a particular part? The whole thing? Yeah, let's go ahead and run through the whole thing. Okay. All right. So a box contains 10 colored light bulbs. We got 5 green, 3 red, 2 yellow. One light bulb is selected at random and put into the light fitting of room A. So the first one, A, really straightforward, just basic probability. What's the probability that the light bulb selected is green? So again, it's just the favorite outcome over the total number of outcomes. So how many green are there? 5. Okay. Out of 10 total. Okay, so the probability of pulling out a green is 1 in 2. Okay. Now the same thing is going to happen for not green. Remember, we could refer to that as the complement when we were looking at sets. Okay. Because there are 3 red and 2 yellow, so there are 5 possibilities out of that. Again, simplifying to 1/2. Okay. So now a second light bulb was selected at random and put into the light fitting in room B. And Karima, you have turned in your quiz. Okay, cool. All right. So what is the probability that the second light bulb is green given that the first light bulb was green? So there's, one of 2 ways you could go ahead and look at this. Is there anything that kind of jumps out at you? Given. Okay, that makes this what? Conditional probability. So if we were to think that the first part, let's refer to that as A, the second part is B, the formula was the probability of the intersection of A and B, let me put that out right there, divided by the probability of B. Okay, so you could absolutely go ahead and run through the formula. How many people actually did end up making a tree diagram for this one? So quite a few folks. You probably could have just pulled this right off the tree diagram as well. I don't even have to, oops. Okay, don't even have to go through the whole thing. Okay, so let's say I have 3 choices in the beginning. So green, red, and yellow. So the probability of pulling the green out, remember we said was 1/2? But now we're in the second room, so the probability of pulling out a second green, well, how many are left now? Okay, there's 4 green out of 9 total bulbs. So it would be 4 nines. So you can look at it, what's the probability of the second one being green given that the first one was already green? Well, it would have to be 4 nines. Okay. Or you could go ahead and run through the formula and go ahead and get the exact same thing. Did anybody want me to go ahead and do that? Okay, so I'm going to go ahead and keep that up right here. Let me write the formula out again. The probability of A intersecting B divided by the probability of B. Okay. So let's go ahead and talk about the intersection. You remember when you were looking at your tree diagrams, the branches themselves were the intersections. Now, if you had more than one branch that had the outcome you were looking for, you added those. That was the what? That was the union. Okay. So the intersection would be just to multiply the probabilities of both of them being green. Okay. So that would be 1/2 times 4/9. So that would be 4/18. So 4/18 would be what? 2/9. There we go. 2/9. So we know this guy right here is going to be 2/9. Okay. And then we want to go ahead and divide that by the probability that the first light bulb was green. Okay, well, the probability that the first light bulb was green was what? 1/2. So I'm going to take this 2/9. I'll just go ahead and do it up here. The 2/9 divided by the 1/2. And what happens when we divide by a fraction? You multiply by the reciprocal. So 2/9 times 2 over 1. And see, we still end up with the 4/9. Okay, questions on that one? Okay. All right. So what is next? Let me go ahead and erase this right here. Okay, so that one was 4/9. Okay, both light bulbs were not green. Okay. All right, so how are we going to go ahead and do this one? Remember, I was talking about there's a way that you could go ahead and look at this without using the tree diagram. Yes, sir.
Could you do the intersection of the probability of the first one being not green and the second one being not green?
The intersection
So
of
it'd
the
be
probability.
like 1/2 times, because the probability of the first ball not being green was 1/2.
Mm-hmm.
And could you find the intersection of that with the probability of the second ball not being green?
Yeah, you could. Mm-hmm. So yeah, so basically it's going to end up looking like the same fractions that you would. I like the way Eli explained it. What I kind of thought about was just taking, just going straight down a branch. Like, what's the probability of not getting a green and then not getting a green? Just following that one right along. So it's going to look the same as if it was green because you have 5 and 5, right? Okay, the 5 being the 3 and 2 for the red and yellow. But the not green, we got 5/10 times, and then it would be 4/9. So I'm going to end up with 20/90, which is where we ended up with the 2/9. Okay, does that make sense? Okay. And then B3, what's the probability that one room had a green bulb and the other room does not have a green bulb? So I kind of did the same thing. Okay. What I did was I thought, okay, there's a possibility that the first room could have a green bulb, then the second room would not have a green bulb, or it could be the reverse, not green and then green. So see, that would show two different branches that have the same outcome. So I would just take the sum of those. Okay. So green would be 5/10 times not green, then we'd have 4/9. Okay. Plus, and then not green, 5/10 times 5/9. Okay. And then I believe I ultimately ended up with, what was the answer? I got 5/9 altogether. Okay. 5/9. Okay. Oh, did I make a mistake?
That first 5/9 be that first 4/9 be 5/9?
This one, yes. I'm sorry. Because green, we have 5 out of 10, then that would be a 5/9 as well. Yes. Well, because see, not green, we've got 3 red and 2 yellow, so there's still 5 possibilities to not have a green.
But you still take one away from the denominator.
Yes, because there's only 9 total left. Yes. Mm-hmm. Did I mess up on the second one too? Yeah, that's 5/9. Yeah. Because this one here, see again, this is why it looks similar, is because you have 5 green, but then you've got 5 of 2 other colors. So it doesn't matter if it's red or yellow as long as it's not green. Okay, was good on that one? Okay. All right. And then we're moving on. The third light bulb is selected at random and put into the light fitting room of room C. What's the probability that all three rooms will have green bulbs? Okay, so basically, again, I just thought about it. Okay, green times green times green. I was looking for that particular branch. So we have 5/10, so that's 1/2. Times, now there's only 4 left out of 9, times 3/8. Okay. And then we can go ahead and start to simplify these. That's 3, 1, 2. So it looks like ultimately I'm going to end up 1/12. There's only 1 in 12 probability that all three of the rooms are going to have. Yes, because when I first reach into this box or bag, whatever it is, you've got 5 green bulbs out of the 10. Then the second time, you've only got 4 green bulbs left out of 9, and then you've got 3 left out of 8. So basically, the probability of just pulling 3 greens, one right after the other. What was that?
They're watching The Office next to it.
Are they?
Yeah, that was the theme song.
Oh, man, I wish I was watching The Office. But, I mean, we're still having more fun because we're doing math. Wait a minute, that was a little bit of a hesitation right there. Okay.
Well, I mean, if it were any other show.
True. Well, okay, I will say this. It depends on what season. If it's after Michael Scott left, yeah.
I don't know. Season 9 was pretty. I like season 9. I didn't like season 8 very much, but I like it.
Yeah.
Each of the scenes has their moments, but overall,
Robert California as a character just sucked.
I love
No,
You loved Robert California, really?
A couple of times I didn't, but after you watch it a lot, I love. Yeah.
No.
I mean, I really like James Spader, but.
I like Joe.
I heard 24.
Hmm.
No, I like Robert.
No, I like.
Okay.
So much more because
All right, so let's see what we got here. Oh, yes.
Okay, I'm just like, the wording is confusing me because, like, it says a third light bulb is selected to put into the light fitting of room C.
So it's talking about, I guess the socket, the housing. I guess what would you call it? Is there where you screw the light bulb in? I don't know.
I know, but just like, it says all 3 rooms have a green light bulb, so why is it still technically?
Well, because it's kind of moving. Because see, part A is only dealing with the first room. Then part B moves on to the probability of colors for the second room, and then now in C we're talking about the third room.
So the rooms are getting light bulbs from the same, like.
Yes, from the same box.
Okay,
So it's like, maybe you got a box of light bulbs out in the hallway and you got 3 rooms, and instead of taking the box into the room, I guess you're going to walk out and just without looking. Because that's what people do, right? There you go. Math. The only place you can buy 60 watermelons and nobody wonders why. You ever, what's really awkward?
this other girl said she was buying like 6 watermelons at the store, and someone saw her and she felt really awkward because she felt like she was in a math problem.
Mr. Perkins at the store for like 6 watermelons in the cart. He just looked at the watermelons and looked at her, and then they didn't say anything to each other, and they just kept walking. And then as like her
That's
more watermelons, she was just watching, really confused.
All right. I love Mr. Perkins. Nobody's agreeing. Okay. I was about to say, Mr. Perkins, awesome. Okay. What's the probability that only one room had a green light bulb? So you remember what I did in the previous ones with the, the green, 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 no green, green. I basically did the same thing here. For the first one, you could go ahead and put, the order I'm going to put these in is like the first, second, and third room. So you could have a green in the first one, then not green, not green. So you could have no green in the first one, green in the second, or you could have green in the third room. Okay. So I'm looking at those individual branches. Okay, those would represent the intersections, and then I would just add those up. But what I found after I actually wrote it out, you're just going to really take 3 and multiply it by 5/10 times 5/9 times 4/8. Yes, because we had the 5 and 5. Mm-hmm. And on that one, what did I end up getting? Was that my 5/12 answer? Yes. Mm-hmm. Did anybody actually want me to go ahead and run through the math on that? Yes? Okay. So do you want me to set it up individually, or are you okay with my just combining all these because they're going to be three of the same types of fractions?
Oh, I get it. Yeah.
We'll do individually so I can see.
Do individually? Okay. All right. Well, let's go ahead and just go here. Let's say the first room does have a green. What's the probability of that happening? So that would be 5/10 times. But now the other two rooms will not have green. So we're choosing from the other five. So there's still 5/9 times 4/8. And I'm not going to go ahead and reduce just yet because I want you to see that we're going to get the same thing over and over again. So if the first room starts out with a bulb that's not green, 5 choices out of 10 times green, 5 choices out of 10 times, now we're going for a not green. Yeah, Lord. It's a Friday. It absolutely is. Okay, there we go. I'm going to get the next one without making a mistake. Okay, so not green, that would be 5/10. Then there's only going to be 4 left out of 9 times
Now that makes sense.
5/8. And see, it's different combinations, but it's still the same collection. Tell me I didn't screw up again.
Yeah, 5/8. No,
No,
that's
that's
right.
right. Yeah.
No, that's right. Just the same three fractions.
Well, they're not the same fractions, but they total out to be the same.
Yeah.
Oh, they do?
Yeah.
I didn't know that. Look at that.
Mhm.
Because it's still, yeah, all the time.
Yeah, that makes sense. That makes sense.
Okay, so we're good? Okay. And then we got this last one right here. C, what's the probability that at least one room has a green light bulb? Okay. So this one I tried to get as clever as I could on it. Okay. That at least the problem here is the fact that it says what? At least. So it could, 1 green bulb would be okay, 2 green bulbs, 3 bulbs. So basically, the only one we're not interested in is.
All non.
There we go. So what I did was I found the probability of 1 minus no G. I almost said no G bulbs. I can't even spell today.
Box.
Wait, can you go over that again?
Okay. You're what?
Well, so can we multiply?
No green bulbs. So yeah.
Multiply the fractions we got for C1 and 2, or like add them, or do something with those.
Well, actually, what I did here on C3, I used C1 because there's only going to be one branch where you have all 3 green, and remember that ended up being 1/12.
Yeah.
Okay. So what I did here was I just subtracted the only branch that exists where none of the rooms got 3 green bulbs.
Wait. Where none of the rooms have 3.
Wait a minute.
Well, like every.
Wait a minute.
Okay,
Hold on.
makes sense.
Yes. All are not green. Oh, I'm going to have to stop today. All are not. I started out so well today, too.
Wait, all are not green. So isn't that just one branch? I know.
Yeah, just the one branch. Yes.
You do that for every time you get a problem that says at least.
I would think so, yes. Mhm. So if you take the 1 minus the 1/12, that's where I got the 11/12. My answers are right. Dang, I'm just not doing good at explaining.
Wait,
Maybe I should stop recording.
Why would the probability be 1/12 for all or not green? Because can't you get like a string of like red, 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 or like.
Well, you could be. Well, it doesn't matter if it's red or yellow. It just matters that it's not green.
They're the same.
Yes.
They're the same.
Mhm.
Oh, okay.
At this point, like how I classify is I like completely get rid of the red and the yellow, and I just combine
Not.
Yeah.
like not.
Oh, that's.
Yeah, that's how I was looking at it. So the other color, red and yellow, doesn't matter. Is everybody okay with that? Is that making sense? Okay, so Haley's good now? Okay, despite my best efforts to confuse everybody? Okay, yes, get it.
Where did you get the 1/12 from?
The 1/12 came from this one. Now, C1 said that all 3 rooms have green light bulbs, but the probability would be exactly the same of all 3 rooms not having a green light bulb.
That's only why.
Because there's 5 non-green and there's 5 green.
We're basically eliminating red and
Yeah.
yellow just combined.
So basically, I took out the one branch,
Not
okay,
green.
where all of them are not green, and then just subtracted that from 1 to 100%.
I see the world in two colors. Green is
Okay.
not green.
It's not easy being green, I'll tell you that. Wow, even my jokes are hitting today, I'll tell you. Obviously, there we go. Wow,
One of those days.
not even a pity laugh, I'll tell you.
Everybody has a thing.
Not that has ever happened before, right? Absolutely, absolutely. Okay, let's see if we can finish this up without me looking ridiculous any further. It's known that 5% of all AA batteries made by power manufacturers are defective. AA batteries are sold in packs of 4. Find the probability that a pack of 4 has exactly 2 defective batteries. Okay, so here's what I thought of. There's 5% chance that the battery is going to be defective, but that also means there's a 95% chance that it's not going to be defective. Okay, so how many possibilities do we have here? Well, for this particular one, overall, I'm talking about there are 16 total. Because you have 2 possible outcomes, all right, because it's either going to be defective or not defective, but then there's 4 packs to a battery. So on this one, I actually went ahead, it's not the best one ever, but I did go ahead and create this. Okay. So what I did,
That's how I made mine.
yeah, I did mine really quick before the bell rang. So
I set mine up differently, and now that I see yours, I'm like, dang, mine is dumb.
well, how'd you set yours
Well,
up?
mine was like, I had like 4 branches for each battery, and then I had the probability of that one being not defective.
Oh.
But that doesn't really make sense, like now that I think about it, and yours makes a lot more sense, because it's like you're grabbing one battery at a time.
Yeah, so mine was thinking about going in order, like the first battery, second, third, and fourth. That's kind of how I did it. Okay. And there are 6 of them. If you go ahead and look through, there are 6. But remember, the question is asking, okay, exactly 2 defective batteries. Well, if there are 2 defective batteries, we know that there are 6 branches where that's going to happen. So what I did was I took the 6 branches, and then I took the 0.05, the 0.95. I multiplied those together, but then I went ahead and squared those. Okay, how do we get the 6?
There are 6 different ways that you can have 2 defective. The first, the second, the first, the third, the first, fourth, and then just
Okay.
go and do that.
Okay. Or if you're like a more visual person, like this one, you could just go through and find all the branches. Like, for example, if I go along here, not defective, not defective, defective, defective. That's one branch. And let's see, if I go through here, I'd have to go another one. So let's go defective, not defective, defective. Then I'm going to go defective, defective, not defective. Then I'm going to go, let's see here. Is that all on the bottom, or is there one more?
I think that's all at the bottom.
That's all on the bottom. So I'm going to go up here, defective, not defective, defective. So that's 4. Then I'm going to go defective, not defective, defective, not defective. So that's 5. I'm looking for one more, and then I can go defective, defective, not. Okay, so there are 6. And you'll notice on each one, those are all the ones where 2 are going to be defective. So every branch is guaranteed to have 2 0.05s and 2 0.95s. So that's why I went ahead and multiplied and got this expression that I had right here. Because there are 2 batteries that are defective, so that also means there are 2 batteries that are not defective. So that would give me with the 4 total batteries. Does that make sense? Okay. I mean, what you could do is, multiply each of those branches individually and then just take the sum of those 6 values when you finish. Okay. Either way, what I got on this one, what was it? 0.0135. Okay. And then at least 1 defective battery. Okay. At least 1. So anybody tell me what they did on this one?
1 minus 0.95.
That's exactly what I did. 1 minus 0.95 to the 4th. Because what does 0.95 to the fourth represent?
Four batteries.
All four are not defective. So there's only that one single branch in the entire tree. So here we just use the idea of the complement to kind of cut down all the work we had to do.
Why did you raise it to the fourth?
Well, because on that one branch, remember, there are 4 batteries, so there's a 95% chance that each of the 4 is going to be just fine. It'll work. Just like in the previous one, 2 are going to be defective and 2 would be effective. Is that good? Okay. Got through that one without screwing up. That's awesome. I got a charge out of that. It's a battery. Okay. Finished with our current problem. That one's kind of a stretch, but I'll still take it. I'm not hitting them out of the park today, so I'll take what I can get. Okay. All right. So there we go. That is that problem right there. Good. Shocking. There, I like that. Hey, nice. Okay. How many Mr. West does it take to screw in a light bulb? Obviously a lot. Hey, come on in, guys. You guys have heard that old joke, right? It's always some different person. Yeah, okay. Yeah. Okay, here we go. Where are we? Review 3. Here we go. Okay, moving on. Onward and upward. Okay, so let's see here. Looks like this first one is going to be a chi-squared problem. For his mathematical studies project, a student gave his classmates a questionnaire to fill out. The results for the questionnaire on the gender of the student and a specific subjects taken by the student are given in the table below, which is a 2x3 contingency table of the observed values. Okay, so they have all the totals for me except how many grand totals should be there. There are 100. Okay. Now, the following table is for the expected values. So it says calculate the values of P, Q, and R. Now, we'll go ahead and run through the calculator process in just a minute, but let's say if we were doing this by hand, if I'm looking for P, the intersection of females and history. So this one right here. What would I do? There you go. For that particular cell, you're going to take the total of that column, the total of that row, you're going to multiply those together, and then we got to do something. There we go. So P would be 42 times 60 divided by the 100, and I want to say I got 25.2. And I'll go ahead and write out one more of them. It wants me to find Q as well. So that would be the intersection of males and history. So again, I'm going to take the 42, but this time I'm going to multiply it by 40, okay, the number of males in the study. And then I'm going to divide it by the total 100, and I should get what? Okay, 16.8 is what I got. And then for R, if you go ahead and do the same process, I ended up with 12.4. Okay. All right. And I can show you once again how to go ahead and figure out, have the calculator display those values for you when we go ahead and plug them in. So the chi-squared test is used to determine if the choice of subject is independent of gender at the 5% level of significance. So state a suitable null hypothesis. So what could we say here? Okay, the choice of subject. The choice of subject is independent, and I'm going to go ahead and abbreviate that, of gender. Perfect. And if you're going to go ahead and write out the alternative hypothesis as well, what's the one thing you'll do? Just add not. Yeah. So I would say make the two virtually identical. Is independent, is not independent of gender. Show that the number of degrees of freedom is 2. Well, what was the formula for finding DF? Yeah. So the number of rows minus 1 times the number of columns minus 1. So the number of rows minus 1, that's just 1. Times the number of columns minus 1, 2 is 2. Okay, so that one was easy enough. Write down the critical value of the chi-squared at the 5% level of significance. Okay, that is 5.99. Now, this brings up a good point. They are not going to require that you memorize, say, that table of values for the calculated ones. If a problem like this should appear on your exam, and I would be willing to bet chi-squared is probably going to show up a couple times, they will provide you that number. Okay, they will provide you that number. It's not part of the formula book, but they will give it to you. Now, it goes ahead and says that the calculated value is 1.78. Do you accept the null hypothesis? Now, remember, what are we looking for if we're going to accept or reject? What's the comparison? I'm going to take the 1.78 to 5.99. Remember, we have chi-squared calculated, okay, and then we have chi-squared critical. So we see here that it's less than. So do we accept the null hypothesis? Yes. If your calculated value is less than the calculated, yes, we accept the null hypothesis. These two quantities, these two items are independent of each other. Now, it's when your calculated value is greater than the critical, we reject the null hypothesis and accept the alternative hypothesis. Okay, so do you accept it? Yes. Yep. All right. So let's go ahead and run through those keystrokes real fast. Let's make sure that we remember how to do that. So let me pull this up. Okay. Okay, so I'm on my scratch pad here. So I know that we got to start with a matrix right over here between 9 and your catalog, right here in the second. So the dimensions are what? Okay, 2 by 3. All right, so it looks like we have 22, 20, not 520, 18. Then we got 20, 11, and 9. Okay, now what? Okay, we want to store it. So control variable. And you can store it as whatever you want. We'll say X. Okay. Next. Menu. Okay, so statistics. Stat tests. Chi-squared two-way because we have a contingency table. Okay. There we go. So we'll type in X, the matrix we want. And there we go. There's that 1.78 they gave me. The p-value is here. Degrees of freedom. How would I pull up my expected values? So variable right here, I used to store it. EXP, the expected matrix. And then push enter. And there we go. There are the values that we went ahead and found for P, Q, and R. Okay. Perfect, 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 perfect. Good. Good. Okay. Well, let's move on over. Okay. So let's take a look at this one. So it moves from a chi-squared to a correlation coefficient regression problem. The heights and weights of 10 students selected at random are shown in the table below. Okay. Plot this information on a scatter graph. Use a scale of 1 to 20 centimeters. Well, we don't worry about that. Okay, now we'll go ahead and do that in a second. For at least the time we have left right now, let's make sure to at least run through the keystrokes. So let's say I go back over here to my calculator. I'll go ahead and graph those in just a second. All right, so what do I do? In fact, let me even go to my home screen. Okay, so you can go to a new document, list and spreadsheets. You can choose this icon down here at the bottom, whatever you like. Okay. Always want to go ahead and label these. I know we're talking about heights and weights, but, X and Y, as long as you know what it is you're referring to. And we're always avoid this equals row. And then let's see here. What do we got? 155, 161, 173, 150, 182, 165, 170, 185, 175, 145. Okay. And then you remember the little trick to go right back to the top of the screen? Control 7. Okay. And then what corresponds to that? We got a 50, 75, 80, 46, 81, 79, 64, 92, 74, and a 108. All right. Okay, so I've got my data in. Median. Statistics. Stat calculations. 2 variable. Okay, now we only choose 1 variable if we have what kind of list? A frequency list. There we go. Good, good, good. Okay, so we're going to go ahead and delete that right there. So the X list is that. Put the Y's right there. There is no frequency list. And, oops, get that back. Oh, it always says one? Oh, it does? Okay. And then everything will show up in the D column here. And there we go. So this is really nice because not only will it give you the means that we're looking for, what's this right here? Okay, sigma x, that's our standard deviation. Gives you both of those for your data sets. Gives you the correlation coefficient. So based on this, would you say we could be expecting a strong or a weak correlation? Definitely weak. Okay. Also, it gives you enough information for a box and whiskers plot. Okay. First quartile, median, third quartile, max, all that good stuff. Okay. Perfect, perfect, perfect. All right, so what's it want me to do? So we want to go ahead and plot the points. We've already got the mean, heights, and weights. So we have the... We already have the grand mean. Okay, so basically we just need to go ahead and plot these points real fast. Anybody want to go ahead and do that? So many people are just coming on up to the computer, smartboard. It's the easiest thing you got to do. You're just plotting a point. So I'll go ahead and label these for you. I counted these by 20s. So 20, 40, 60, 80, 100, 120, 140, 160. And how far did I go? I went all the way to 200, 180, 200, which is right there. And then the vertical axis, I counted by 10s. So I said 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. We're up to 110. Okay. All right. Who wants to come on up and show me all these points? So many people. Okay. Well, I guess then I'll just go ahead and put those on very quickly since nobody's coming on up. Let's see. So 155 will give me 50. So 155 right here. Okay. So 155 will give me 50. Then 161 is going to give me 75. Okay. So I'd say right about here. Okay. 173 is 80. Okay, so 173, maybe about right there. Okay. Oh, no, wait. Oh, crap. See, this is why I asked for help. And nobody came up here. 150, 46. Okay, so 150, 46 would be right about here. This is the exciting portion of the lesson. 182, 81. So 182, and then just a hair higher than that one. 165, 79. So 165, 79. Let's say right there. Then we have 170, 64. No. Okay, so 170, 64, maybe about right there. Okay, 3 more to go. We're so close. 185, 92. Okay, so 185, 92. Let's follow that over. So right about here. 185, 92. Okay. And then 175, 74. Stay right about here. And then we have our outlier 145, 108. 145, 108. There we go. All right. So what do we think of the scatter plot?
Beautiful.
Thank you. It's on point. Okay. All right. Yes, thank you. Come here.
Did you care about the scale really, like how it said
honestly, in these different resources where I'm getting the review problems from, I'm finding that more and more they're very specific about how they want you to go ahead and set up these scales, but I've never seen that show up on a paper exam. Okay, not yet anyway. I don't believe they would ever do that because you're against the clock. You've already got enough stuff to worry about. If they do want you to draw some kind of graph, they should be providing you the grid or by some means of doing that. Okay. All right, so what do we have here? 205. Then we'll go ahead and stop there. Has anybody actually completed review 3? Almost done? Okay. All right, so you also have review 4, so we're close. You'll get review 5 on Monday. Remember, I'm not here, so take the opportunity, work on those, and we'll just continue when I see you Tuesday. All right, so let me go ahead and save this so I don't have to plot all those points again. You want to save changes? Yes.
I did. But I did.
Guys, check your numbers.